Hello guys, welcome on Tesla Adventures. In this video, we are going to discuss the pure resistive AC circuit. So you can see that there is a pure resistive circuit in which a sinusoidal voltage source V is equal to V naught sine omega t is connected. Now if we find out the current flowing in the circuit, then we can directly say then that the current will be V by R, and V is V naught sine omega t divided by R. So I will be equal to I naught sine omega t, and this I naught is the peak value of current, will be numerically equal to V naught by R, where V naught is the peak value of voltage. So first of all, we should notice one thing, that the phase of voltage is omega t and the phase of current is also omega t. So we can say that in pure resistive circuit, the current and voltage are in same phase. Current and voltage are in same phase in pure resistive circuit. So the phase difference between current and voltage in pure resistive circuit is 0. So this is the first thing which we can definitely claim. As well as if we draw the phasor diagram, if we draw this phasor diagram, so let me draw it. So this is the phasor diagram at t is equal to 0. So at t is equal to 0, we can say that the phase of current is 0 and the phase of voltage is also 0. So we can draw the current on this x-axis, because we are considering the phase as angle, and all angles are measured with the x-axis, so we can draw the current on x-axis. This is voltage again, and they both are lying on the same direction, which means that they both are in same phase. But if we draw the diagram, the graph in fact of current and voltage with time, so this will be the graph of voltage, which would be like this. Okay, this is t by 4, this is t by 2, this is 3t by 4, and this is t. Okay, and this is voltage. Now if we draw the graph of current, okay, this is the graph of current. So the graph of current will also look the same. It would be like this. Okay, and this peak value will be V naught and this peak value will be I naught. In fact, this is the current. Okay, and these two graphs are exactly same except these coordinate values, which shows that in pure resistive circuit, voltage and current are in same phase. Now if we discuss about the power loss, so although we have already discussed about the average power loss in the previous video, but let me again remind you that average power loss here will be VRMS, IRMS, cos phi, and because phi is 0, so cos phi will be 1, and IRMS will be equal to VRMS upon R. Okay, so average power loss will be equal to Vrms into Irms, which is Vrms upon R, and cos phi is 1. So it would be equal to Vrms ka whole square upon R. This would be the average power loss in this pure resistive circuit. Okay, so this was it in this video, and in the next video we'll be discussing pure inductive as well as pure capacitive circuits. Thank you.